Hello, ladies and gentlemen. My name is Mekal Vashit Reddy, currently pursuing my BTech at Institute of Aeronautical Engineering at Dundigal, and my specialization is artificial intelligence and machine learning at CSC specialized branch. So today we are going to discuss a topic which is Bayesian analysis of Bayes theorem. So let us dive deep into the topic. So these are the topics we are going to be discussing tonight, which are Bayesian analysis of Bayes theorem introduction, Bayes theorem, Bayesian analysis, example applications. So before we introduce to this topic, this Bayes theorem is basically said as the branch, or let us say is like a backbone to probability and statistics, where regarding Bayesian theorem, we have multiple applications in probability and statistics, as we all know. So let us introduce this Bayes theorem. So A method, so Bayes analysis is a method of statistical interference named for after English mathematician Thomas Bayes that allows one to combine prior information about population parameter with evidence from information contained in a sample to guide the statistical interference process. Application of Bayes' theorem to provide posterior probability for the parameter. The posterior distribution provides the basis for statistical conquering the parameter. Importance of Bayesian analysis in decision making. Bayesian analysis is a statistical method that allow researchers, decision makers to take into account data as well as prior beliefs to calculate the probability that an alternative decision treatment is superior, developing criteria prior rating of options and calculating assessments and final assessments are included the analysis. An example is provided to show how laboratory compare routine hematology autonomous alternatives, cell counter, automated microscopes, and automated cytometry cell counter using Bayesian analysis technique. So, these are some of the subtopics regarding Bayesian analysis. Posterior probability or distribution, updated probability after evidence is considered, prior probability or distribution, the probability before the evidence is considered, likelihood, probability of evidence given the belief is true, marginal probability, probability of evidence under any circumstances. So here is a formula which is used to calculate Bayes theorem. So here we can see py comma theta is equal to py by theta, which is basically a conditional probability statement which we'll later on discuss, into p theta, that is equal to p theta by y into py. So this is a condition for Bayes theorem. So post P theta by y is equal to Py by theta into P theta by Py. So here P theta by y, which is obviously the conditional one, is a posterior distribution. Py by theta is likelihood. P theta is the prior distribution, marginal distribution. Py is equal to integral Py by theta into P theta d theta is a marginal distribution. So prior probability in Bayesian statistical interference is the probability of an event occurring before new data is collected. In other words, it refers the best rational assessment of probability of particular outcome based on current knowledge. An experiment is performed. Bayes' theorem states that the conditional probability of event based on the occurrence of another event is equal to likelihood of second event given the first event multiplied by prior of first event. Bayes' formula is tool for updating the probability of an event uh, of an event of an event being true. With information, we start with prior probability, then obtain information from the test and thereby update prior probability with posterior probability. In the context of Bayesian analysis, the step of evaluating results and iterate refers to the process of examining the outcomes of analysis, accessing their validity and reliability, and refining the analysis through iterations if necessary. The steps play a crucial role in Bayesian frameworks as it allows for continuous learning and improvement based on new evidence or feedback. During this evaluation phase, uh, several aspects need to be considered. Assu- Accessing the fit, evaluating how well posterior probabilities align with the observing data. This involves examining the extent to which the analysis captured the underlying patterns and trends, exploring the sensitivity of results to different assumptions. By carrying these words, you can observe the impact of prior probabilities and identify a- any potential barriers or limitations. Incorporate Incorporates prior knowledge. Uh, so let us discuss some of the advantages of Bayesian analysis. Incorporates prior knowledge. Incorporates prior knowledge in Bayes' theorem means using existing information or beliefs to shape the initial probability distribution. The prior knowledge provides a starting point for analysis and can influence the prior probability estimates based on new evidence. Um, it allows for the integration of subjective judgments or domain experience into analysis. Bayes' theorem activates accounts of uncertainty. Bayes' theorem accounts for uncertainty by respecting probabilities as distributions rather than single values. If quantifies the uncertainty associated with prob- prior beliefs and updates them on observed evidence, providing a prob- probabilistic um, measure of uncertainty in posterior probability. This allows for a more comprehensive and nuanced representation of uncertain information in analysis, allows for iterative learning. Bayes' theorem allows for iterative learning by providing a framework to update prior beliefs with a new as new data becomes available. The posterior probability can be calculated in incorporating the fast, fastest and latest information. The iterative process enables continuous refinement of analysis, improving the accuracy and reliability of results over time. So, as we discussed earlier, here are some of the real life examples of Bayes analysis for Bayes theorem. So, let us say in a scenario of diagnosing a disease, let us say HIV. So, World Health Organization had to create a list of or who probability of people who are diseased such that prevalence. So here prior probability, prevalence of disease, likelihood, diagnostic test accuracy, update, diagnosis probability, importance of base analysis in medical decision making. So yeah, so here we can see as I zoom in. So yeah, prior probability, that is prevalence of disease in population. P plus ID, likelihood function, that is probability of observing positive test given that the person is likely diseased. D by plus is equal to D P of plus by D into P of D by P of plus. P of plus equal to P of plus by D P of D plus P of plus by D bar into P of D bar. So another example as we see. So here is a small um, WHO survey as conducted. So here we can observe 10,000 intravenous drug users, um, and by using base analysis 2375 true positive test results and 30 false results. So yeah, so as you can observe. So fraud detection. In recent times, it has been very common uh, for any caller to receive any fraudulent calls, which may cause a huge number of money loss and time loss. So to avoid that, uh, Bayes theorem is used for detection of credit card fraudulent. Uh, prior probability of prior probability, prevalence of fraudulent transactions, likelihood, patterns, and indicators of fraud, posterior probability, update probability of fraud, importance of Bayesian analysis in fraud detection. So here you can see. Um, so the answer for that is total transaction equal to 100%, overall fraudulent transaction equal to 1%, genuine transaction equal to 99%, uh, fraudulent transaction not in our country, uh, genuine transaction take place in the country. If transaction has not taken place in the country. So by using Bayes analysis, we may get 0.01502 uh, as the probability. Okay. So application of A/B test. Uh, so comparing two website versions, initial beliefs about conversation rate, user engagement, and conversation data. Conversation data. Update conversation rate probability, importance of Bayes analysis in A/B test. P of x greater than 1 is equal to the whole thing 1 minus summation of j equal to 0 c minus 1 b of a plus j by co- b plus d by d plus j b of I plus j comma d b of a plus b. Okay. So incorporance of visual effects, steps graphical representation of a Bayesian analysis. Steps can provide a visual understanding of process. One commonly used in is Bayesian network, which illustrates the relation between variables and flow of probabilistic reasons. The nodes in diagram represent variables and edges depicts dependence, use of chart, illustration, prior likelihood and posterior probabilities, uh, visual and uncertainty, histogram and probability distribution. Uh, okay. Bayesian analysis in machine learning. Bayesian interference in machine learning involves updating prior beliefs about model parameters based in observing data. Uh, okay, probabilistic framework. Okay, so thank you all. I hope you like this video. Please like and subscribe. And yeah.